Alright, so what if we had to write an equation for a graph of a square root or cube root that we were looking? First, we'd have to figure out which equation to use, whether it's a square root or a cube root. Then if we're using a square root, if it goes to the left, then we have to we have to remember to put the -1 in there to make the x negative. Otherwise, we will in fact not get our graph to go to the left like it's supposed to. If our square root goes to the right, then we choose the original formula with x minus h in it. We'll locate h and k off of the map, off of the graph, and plug that in to the correct space in the formula. And then we'll pick some other point on the graph to use as x and y, so that we can plug that into the equation and solve for a. Once we know a, we can write the equation. Let's try it out. Okay, first we can tell that this one is a cube root because of that decreasing shape. So our form will be y equals a times the cube root of x minus h plus k. Okay, so h and k is that middle value on the graph. H and k is not this highlighted point. This highlighted point is going to be helpful for x and y. H and k is the one that's in the middle of the curve. So where it stops scooping one way and starts scooping the other way. Right there. You can tell we have a symmetry. It's one space to the right and two spaces down to this point. It's one space to the left and two spaces up to that point. So we can tell we're in the middle that way. Alright, so this value is 2, 7. So h will be 2, k will be 7. We'll start there. So y equals a times the cube root of x minus 2 plus 7. Notice the plus 7 is not inside the square root. So now we need a point that we can plug in for x and y. So that's this highlighted point. We're pointing out a good one for you to use there. That would be 3, 5. So for the x we'll put 3 and for the y we'll put 5. So 5 equals a times the cube root of 3 minus 2 plus 7. So inside the radical there's math to do. 3 minus 2 makes 1. Okay, so 5 equals a times the cube root of 1 is 1. So a times 1 plus 7. So we'll work backwards. We'll subtract 7 to the other side. So -2 equals 1a. So -2 equals a. So if we just plug that in right there, we'll have our equation. Y equals -2 times the cube root of x minus 2 plus 7. Sure enough, that's a cube root that decreases, so it very much agrees with our picture. Okay, so let's try a second example. This time we can tell it's definitely a square root. So we'll start with y equals a times the square root. And we'll notice that it goes to the right. So we'll pick x minus h plus k. K outside the square root. If this had gone to the left, we would have picked the -1 version, but it was not. Okay, hk, remember, is your starting point. Again, it's not the point that's highlighted. You have to find it yourself. 1, 6. So y equals a times x minus 1 plus 6. Okay, in order to find a and to complete the equation, we need a point to plug in for x and y, which is this point right here, which is 5, 8. So for x we'll have 5, for y we'll have 8. So 8 equals a times 5 minus 1 plus 6. Oh, wow. Plus 6. Okay, so we can complete inside the square root. We can get 8 equals a times the square root of 4, add 6. If you're doing these right, you're going to get nice pretty square roots. The square root of 4 is 2. And now we can work backwards. We'll subtract 6, so 2 will equal a times 2, otherwise known as 2a. Divide by 2, and a equals 1. So if we plug that in right up here, we'll have our equation. Y equals 1 times x minus 1, and then at the end plus 6. Make sure that plus 6 stays out of the square root. Okay, that's a 1 that you didn't have to write to be correct. You could have just written a blank square root of x minus 1 plus 6 since a was 1. Okay, third and final example. This one again is a square root, but this one we notice is headed left. So we have to remember to put in the negative 1 in front of the x minus h. Notice the use of parentheses, plus k. If we forget that negative 1, our graph will not go left. We have to have a negative, making that x be negative, or it will not do what we need it to do. Okay, hk is the starting point. That's right here. That's 5, 4. So hk. So we'll plug that in. Y equals a times parentheses negative 1 times, negative 1 times parentheses x minus h was a 5 plus 4. If you ever needed to plug in a negative number for h, it would be negative negative. It would turn positive. All right, we need to put in a point for x and y. So that's this point. That is negative 4, positive 1, x, y. So 1 equals a times the square root of negative 1 times the quantity negative 4 plus, nope, that's minus, sorry, negative 4 minus 5. Make that square root a little longer there, and plus 4. So I want to deal with this. I know that if I put negative 4 and negative 5 together, that'll be negative 9. So it's negative 1 times negative 9. If I forgot to put my negative 1 in, right now I'd have a problem because I would have a negative inside my square root. But instead I remembered my negative, so I have positive 9 inside my square root, which has a nice pretty square root of 3. If you get an imaginary number, it's a hint that you forgot your negative 1 to make your graph go left. So we just need to subtract 4, which gives us negative 3, equals to 3a. And if we divide by 3, we discover that a is negative 1. So if we plug that in right there, we'll have our equation. Y equals negative 1 times the square root of negative 1, parentheses, x minus 5. Oh, that's a little messy. Let's try that again. X minus 5, and then outside the parentheses, plus 4. You do not need to distribute the negative 1 inside the square root. This is a perfect way to leave it. You do not need to make that negative x plus 5, even though that's a textbook would have it written that way when we graph it. Alright, hopefully that helps you with level 2 questions where we write the equation from a graph.